So I'm going to walk through the Reclaiming Copper Lab. I suggest as you watch or listen to this video that you pause at each section and complete it along with me. That way it'll make more sense as we continue on through the end. So this is an engineering design lab, meaning that part of your task is going to be to design the experiment based on a scenario. So if you read part 1, it says you work for an industrial chemical company and you've been given the task of reclaiming the copper metal that's currently dissolved into this solution here of copper 2 chloride. You decide that a single replacement reaction is the best way to complete this task. Basically, all this means is that inside this beaker is copper chloride. We're going to take some unknown element. I'm going to put it as a box because we don't know what we're going to use yet. But this element in a chemical reaction is going to replace this copper in this compound. When it does that, the copper is kicked out and it forms a solid, okay, that we'll see as our experiment moves along. That's why it's called a single replacement. I have a single element that's going to replace copper in this solution. So when we're choosing this unknown element, we're going to look at a few different things. The first thing is we're going to look at what we call an activity series. Okay, so here is copper right here. And what this activity series means is it means that it kind of lets us know how reactive each of these metals are. So the higher up on the scale, the more reactive the element is. So if we want something to replace copper, we want to choose something that is above copper, so that is somewhere in this upper range here. Anything that's below copper is not going to work in our reaction. There's no reaction will take place. Okay, so that's my first step. My other step is I have a chart here, and these are kind of the options that the company has given me. One thing to keep in mind, since this is a real life scenario, if you're working for a company, they're always going to want you to do your job for the cheapest amount of money. Okay, so when you're choosing your elements, you're not going to want to choose the most expensive option because your boss will not be happy with that. Okay, he wants you to be able to do it using this least amount of money as possible. But again, you have to make sure it falls within this upper arrow range over here. Otherwise, your reaction will not take place. So once you choose, you're going to put your metal in this box here, okay? So you're just going to write your symbol there or write the name. So now that we have chosen our metal, we're able to write our reaction. So we should have chosen aluminum because it's high. It will react with copper. It's higher up on the scale, and it's also the least expensive. Now we can write our chemical equation. So you can see in this reaction, and this should be a little arrow here, it didn't transfer over well. We can see that this aluminum has kicked copper out. So now my aluminum chloride is what is dissolved in my solution, and I'm going to have a solid copper substance that we'll see kind of reacts out of the solution. So the first thing you need to do is balance this equation. Okay, so I would suggest pausing here, balancing your equation. Next, we have part 2. Okay, so what this part, we're actually going to perform our stoichiometry. And down here, I have it kind of partially set up for you. So you're just filling in you're just basically filling in the number signs, okay, with the correct value. So your goal is to reclaim 0.2 grams of copper. So that's what we're given. So that's what we're going to start with in our equation. Okay, so what we're looking for is we're trying to find out how much of this copper chloride we need to make this to make this amount of copper. So you can see this is what we're looking for. That's what I have at the end, right? How many grams we're going to need of this copper chloride. So I've given you kind of your steps. So we're starting with grams, okay? So for this step, the first step, right, we're using our molar mass. So that's what you're going to put in here, your molar mass of copper, okay? The next step, we're converting between our moles of our given, our moles of our unknown. So we're going to need to use our mole ratio. So that is this right here. Okay, remember our mole ratio is our coefficients in front of our equation. So we're going to be using the mole ratio here of copper and the mole ratio here of copper chloride. The last step is converting between moles of what we know or what we were looking for that we have now and converting it into grams. And again, we're going to use the molar mass. That has already been filled in for you in this step. Okay, so you don't have to do anything for the last step. So now you should be able to have plugged everything in. You multiply across, divide by the bottom, and you should get your final value of your copper chloride. So that's telling us how much we're going to actually start with in our reaction. I would pause here, make sure you've completed this, this equation. Once you finish, you're ready for part 3. This is the actual lab portion. So you're going to click the link in your document and you're going to watch the video that walks you through the lab procedure. So you'll see how you will start with a certain amount of this copper salt, this solid, dissolve it in water, and then you'll actually begin your reaction with the aluminum. Make sure you're filling in the data table as the video goes along. You may need to pause. Observations, you just want to make observations. You know, what does your solution look like at the beginning? You know, some before and after observations. You may also want to look at, you know, what are some signs that a chemical reaction is occurring? So are you seeing bubbles? Is there gas formation? Is there a color change? Okay, so those are just some things that you could make observations about as you watch the video. Once you've completed that, you're moving on to part 4. These are just some calculations and some post-lab questions. So number 1, you're looking at the picture. This is showing you what's happening in the reaction at the molecular level. So what's actually happening that we cannot see. You're just writing down one thing that changes and one thing that stays the same. Okay, make sure you're paying specific attention to your solution. Remember, we started with a copper chloride solution, okay, with aluminum, and then notice at the end, our final, right, there's something different in our solution that you should be able to point out. For step 2, this is filling out part of the chart. You're going to take your initial mass of aluminum and subtract your final mass, and you'll figure out how much aluminum was actually reused. So that's these two values here. Okay, so you should be able to tell me how much aluminum was actually reacted in this chemical reaction. And then the third step is you're answering what is the limiting reactant. So remember, limiting reactant is the reactant that gets used up first. It's going to run out. So which of my two, make sure you're choosing between your reactants. So let me scroll up to my chemical equation. Remember, my reactants are at the beginning of the equation. Those are my ingredients. So you only have 2 options for what is your limiting reactant. It's either aluminum or it's copper chloride. Okay, so which one of those ran out first? Lastly, we're going to calculate the percent yield for the copper that you produced in the reaction. So you're just, again, filling in the number signs with the correct value, and then you're solving. So in order to calculate percent yield of copper, you're going to plug in your actual yield. So this would be from your data table, the final mass of copper that was produced. Your theoretical yield, that's what we calculated at the very beginning. That's what your boss told you he or she wanted you to produce, okay, 0.2 grams. That was what we based off our whole lab on, was this 0.2 grams, right? That was what our calculation says we should have produced. So you'll take your actual value from your data table, divide it by 0.20, multiply it by 100 in order to get your percent. Okay, so that is the final question in the lab. Hopefully this helps, and feel free to reach out with additional questions.